Hello everyone, so today I'm going to give a quick talk about brushless motors and mainly VESC speed controllers. Steve Sloan and JD Parr have done some great videos already, so I'll link to those below, but I'm just going to give you a bit more talk about theory, different motor types and some extra settings. So both of these are brushless motors. We have a hoverboard motor here and a brushless sort of hobby motor here. So with brushless motors there's various different settings. So apart from this little hobby motor, all the motors I've got are 24 volts, and this one here, hobby motor, has 3 wires for the phases. The big one also has 3 wires here, but the big motor is what's called sensored. So it has Hall sensors in the motor, so you can get position feedback of when the motor is turning. So one of the factors that's important on brushless motors is the number of magnets inside. So if you've got more magnets, you get more torque. So it's easier to explain on this one. This is why I've got it. So this is almost the same as the bigger one, but it's a lot smaller, and you can see inside. So the coils are in the middle and the magnets are on the outside. So it energizes the coils in turn, and that causes the outside to spin. So you can see this is basically the same as that, but smaller. So if you count the number of magnets around the side, you can tell how many poles it's got. In this circuit, or this example, there's 14 magnets, so 7 pairs. And also, one of the things that's important with brushless motors is they all have a speed rating. So if I say focus, so it's 268 kV. So for every volt, it will spin 268 times. Oh, you'll have to trust me. So right, let's get rid of that one. So this is a hoverboard motor, which is a good example to start with. So counting a number of poles in this is, I say, almost impossible without taking it apart. What you can do is, if you short 2 of the sort of main phase wires, it acts as a brake on the motor. Then I think this one here, I actually put a marker on and put it in a vise. So when you turn it in a vise with 2 of the phases locked, you can actually feel a distinct jump. 1, 2, 3, 4, 5. So you can actually count when it turns, and you have your marker. So you go like 1, 2, 3, 4, 5, 6 until it comes back to the same position. Count how many steps it did, and that's the number of poles. So if it was this hoverboard, I've got 30 poles, so 15 pairs of magnets. So this is important, which I'll come back to later. So everyone is using, or not everyone, the general consensus is the motors from Amazon, which are these ones. I've had to scribble on what they are, not because I'll forget, but because they're 2 very similar. So at the time of purchase, I got this one for £44, and they do differ. Some are like 90. 44 is the cheapest. These are about 57 now. I think someone, obviously people are buying them all up. I did the same with this, basically locking 2 of the phases and doing it, and these have 20 poles, so 10 pairs of magnets. For the Amazon motors, it's a real minefield. I spent ages on AliExpress and Amazon. Some are listed as L Faster as the manufacturer, and they, in the specs, show either 1600 RPM or 900 RPM, and you can see these in some of the Amazon specs, not all. So you can see why I've labelled them now. So this is a motor from UU Motor, and these are the ones that sort of Tim Hebel uses in his B2. So you can actually see them side by side, and they look basically identical, but they're not. Both 20 poles, both 24 volts, and you'll see later when I test them how they are different. So I say when you buy them, unless it's got a speed rating on it, it's, I'd say, impossible to tell until you test them. So let's get these out of the way. Oh, I should say, for the UU motor, the specs on the website are between 250 and 400 RPM. I can't remember how many watts they are, but I'll put that on the screen. So when I purchased the 4-inch UU motors, I also purchased a 5-inch for testing. This is also 24 volts, and it's rated at 400 to 500 RPM. Same principle. I looked at phases, counted the poles, and these are 20 poles, so it matches what the website says. Lastly, you'll see I've got too many motors to start with. This is the Q85 motor, whereas the other motors for hoverboards, UU motor and the ones from Amazon, are all sort of ready to go. The Q85s require taking apart and sort of modifying. So these are probably fallen out of fashion now because of modification needed, but they're still used and they're still good. So this is a, let's say, 250 watts. Also forgot to mention, some motors come with single shaft, some come with dual shafts. When I use some motors, I like dual shafts because I like it to be held like that. I don't like, say, floating axle. It's easy to hold it and get more grip. So this is tricky because all the other motors are direct drive, sort of like this one. So you apply voltage and it spins. This Q85 actually has a planetary gearbox inside. So when you lock two of the phases and turn it, you almost get like little micro steps. So it's hard to work out the number of poles. The best way is to actually take it apart, and I have done this and I've counted number of poles, and I've completely forgotten how many. One of the important things about brushless motors is you have to have a special brushless motor controller. So you can't use like Sabertooth or Siren, which are used for traditional brushed motors. So these are different but very similar speed controllers. So I say in the past with Q85s we looked at using the Robotex, which are expensive. Now it tends to be the VESC Flip Sky speed controllers, the cheaper option. So this is the old, I would say older, but it's sort of still current, the 4.2. Here we go. So rated from 8 to 60 volts, 50 amp continuous. We'll ignore the 150 amp. To be honest, if you're pulling 50 amps per motor on a R2, you are in trouble. We shouldn't be pulling anywhere near that current. This is the 6.7. So this is a newer one I bought as a test. This is showing as 70 amp continuous. You'll have to trust me. They're more or less identical in the software. These ones I bought from AliExpress. I think they're about 60 or 70. This one I got on Amazon. Weirdly, it was cheaper than AliExpress. I think it was about 67 each, and obviously you need two, one per motor. With the testing, I'll use the 4.2. So yeah, just to show. So so I've got the sort of battery connections here. So this was actually wired for 12 volts, but I'll rewire it for 24, 2 batteries in series. This is going to the transmitter, receiver. You've got the 3 phases out. These are labelled as ABC. Sometimes you'll see them as UVW, and you've got various ports here. This is the important one, which is the connection to the Hall sensors for the censored brushless motor. I'm just quickly going to talk about VESC and settings you can make. Lots been covered by JD and Steve already, but I'm just going to go into a few extra settings, but I'll just quickly scan through the setup. So setup mode, so I've connected to the VESC speed controller. I'm going to go setup motors FOC and do a configuration. So I want to restore to our defaults. So it's generic motor. It's an e-bike hub motor. Yep. So I'm using nickel metal hydride 12 volts. So roughly equivalent to lead acid. So using 2 in series for 24 volts. Battery capacity, that's fine. I'm using direct drive because it's no planetary gearbox. From the testing we know we've got 20 poles, so you can notice we're even numbers because we have to have a pair of north and south, so 20 poles. Run detection, and you'll see the motor spin, hopefully. So I forgot to say earlier, the VESCs are pretty good with the Hall sensor wiring. You don't have to say which way the Hall sensor wiring goes, it just automatically detects it, unlike the previous Robotechs where you had to specifically wire it in order. Also forgot to say, I've got a current meter, so sorry, not voltage meter even, I'm running 26 volts, so I'll come back to that later. So the motors are all set up now. There's one extra setting in FOC. I always forget where this is. Just to make sure the motor's configured correctly. These should be red. I've run it previously. You run RL and it does some settings, and then you run lambda and it does some extra settings, and then it all comes as green. I'll be honest, I don't know what it's doing at this point, apparently it's better. And then just click apply and all's good. So now we go back onto Wizards and do setup input. Gone into setup input, comes with this. I'm going to use a ppm output because I'm using standard RC. Next that, and I get to this window. So even though RC is supposed to be 1 millisecond, 2 millisecond pulse, it's not really. Here you can see centre is about 1.48, maximum is about 1.87, minimum is about 1.1, so you are missing out on the full swing. So by changing this we get the full swing within the motor software. So we do set it to minimum and go read current settings, and it puts minimum here. Maximum we do read pulse at end, and it does the maximum, and then automatically working out centre. So if we go down here, I'm going to set a dead band down to 5%. If we get any sort of wobbles later we can change it. So I'm going to apply that and then go next. Because I want forwards backwards on a motor, I'm going to go current, sorry, duty cycle even, and that's fast. So you can see here duty cycle, and I'm going backwards and forwards, which is great. And now I'm right to VESC. You can change these settings again, which Steve and JD have discovered. Right, so now we'll go next, finish. So back to motor. So now I've got forwards, backwards. I say every now and again I've got cool little toys, and this is one of them. So it's actually a speedo. So if I go here, and I've got a little tab I was using for position, it also is going to tell me RPM. So if I go full speed here, it's showing as basically, let's see if I can get it on camera. Here you go. 1,000 RPM. If I do it the other way, just to make sure it's the same both ways. Yep, so 1,000 RPM. So if I, in the software, I can do real-time monitoring. In theory, basically, based on the 4 inches, that's given me 16 kilometers per hour. And as you can see, it's pretty quick. So, same a personal view for an R2, this is pretty too quick. So, we know we're running at 26 volts, so we can do a calculation to get the kV rating. We know we're getting 1,000 RPM, 26 volts, so kV is. So now I've moved over to the UU motor. You'll have to trust me, they do look the same. This is one of the reasons I've got the sticker on. So I've just gone through exactly the same process. I've configured the motor from scratch and changing the lambda and other time settings, and gone on to real-time monitoring. So for the Amazon motor, we were getting 1,000 RPM, so, and 16 kilometers per hour. So with the UU motor, you can see it's going at only 10 kilometers an hour, so it is slower. If I get my toy, do some testing, I'm basically getting 660 RPM. Oh. And I get the same both ways. So you can tell this is slower than the Amazon motor. However, with shipping and stuff, it was more expensive. From the UU website, the 4-inch motors rated between 250 and 400 RPM. So I am getting over those numbers, unfortunately. So it is sort of faster than their advertising. I'm going to change some settings now so you can see how you can tune these motors. And again, this is where the sort of number of poles comes in and makes it a bit more complicated. So one of the extra settings you can use to change speed is the ERPM. So here's a motor, same speed, forwards, backwards. By going into general and then RPM, you get this max ERPM. So ERPM is the RPM times by the number of pole pairs. So not the number of poles, so this is a 20 pole motor, so number of pole pairs, so it's 10 poles. So at the moment the maximum speed is 100,000, and I was getting a maximum speed of 660 RPM. So if I change this down to 3000, which is basically 300 times 10, which is 10 pole pairs, 20 poles in total. And if I write that to the motor, you'll see, so one way is definitely slower and the other way is definitely faster. So if I go back to start, you'll see speeds 5 kilometers per hour going one way and -10 the other. So if I go back into ERPM, so that's 3000, and just to double check it, we use my speed RPM. And I'm getting 300 RPM. So it's doing as I say in the box. So just to prove a point, if I go down to 1500 divided by 10, right configuration, it's a lot slower. So if I test it, I should be getting 150 RPM, and I'm getting about 163. So that is a way to limit the motors. You've got to be careful though, because if I go too slow with this, let me just go back and show you. So if I go down to 700, write this to the motor, it can become a bit jerky, which isn't good. So it doesn't like going at slow speeds at 24 volts, and there's a way to get around this. So what I've done now is, for the motors, I've actually reconnected wiring, so I'm only going to a 12 volt motor now, not 24. So I haven't made any settings in the VESC tool. So let's just, if I go this way, I'm getting -5. Previously I was getting 10 kilometers per hour, so half the speed makes sense at half the voltage. If I go the other way, it's still a bit clunky. So what I'm going to do is rerun the settings, but instead of no, don't want to do that. So okay, lead acid, I'm only going, say, 1, so I only want 12 volts in total. Okay, all the others are going to be the same, so I'm just going to leave it like that and wait for it to do its thing. Cool, so it's done. Finish it. You can see sometimes it really doesn't like settings and jumps around, so you have to be really careful doing some settings, because if a motor behaves like that, you've configured it incorrectly. So what I've done after a clunky motor is I've gone back and changed the ERPM value to 1500. Now if we go back to the thing, we've got real-time monitoring. So 5 kilometers per hour one way, because I haven't changed that value. The other way I'm going to 3 kilometers an hour, so it's a lot slower. Let's just do a quick reading of the speed. So 171 RPM. So you've got to be careful going too slow with these motors, because otherwise it does jump. There's a sweet spot that you can go down to, and you have to test that. One thing is you can also look at whether you run the motors at 12 volts or 24 volts. They're rated for 24, but you can change the settings. I did find with one of the other motors, when running at lower speeds, it was better at 12 volts rather than 24. This is a hoverboard motor. So a lot is down to testing, and the ERPM is a nice way to limit the speed of the Amazon motors, so they're not as fast and not, say, too dangerous running at 17 kilometers an hour. Just as a quick aside, I've got the hoverboard motor connected, redone all the configuration. This is 166 millimeters diameter. If I do a speed, it's running at 24 volts. I'm getting 6 kilometers an hour. So I've worked out the kV rating and it's 13.6. One of the important things with this motor is it's actually got 30 poles rather than 20. So if I go into, just to prove a point, ERPM, so if I do 1500 divided by 15, because it's 15 pole pairs, should be 100 RPM. So if I write the configuration, so it's full speed one way, but you can see it's sort of skipping, so it doesn't like the lower RPMs, but you can see it's running at 2 kilometers an hour and about 107 RPM, but obviously doesn't like running at 107 RPM at 24 volts. Done a bit of testing, got hoverboard motors running at 24 volts. So if I take it down to a max ERPM of 2000, it's a bit jumpy at full speed. I've taken it down to up to 2500, written the configuration, and it's no longer causing a motor to jump at full speed. So I probably could do a bit more tuning, get it somewhere between 2000 and 2500, but this is setting the maximum electronic RPM, so it's a way to limit the motor speed. So at 2500 and times or divided by 15, because it's 15 pole pairs, I get a speed of 166 RPM, which is basically what my gadget's showing. So it's a good way. So if I go full speed one way, I'm getting 355. Once I limit it, it's basically going half speed at 167. So you're not running a motor at full speed. Just going to explain about minefield motors. So these are the UU motors that, again, Tim Hebel uses on his B2. These were some of the slowest on paper or 4-inch hub motors I could find. I couldn't find any slow ones on AliExpress, so I used these. Here you can see it says, 10 poles, 50 to 100 watts, rated speed 250 to 400, but I get about 660 RPM, so yeah, a lot quicker. These are the 5-inch for comparison. Again, same number of poles, 100 to 250 watts, 400 to 500. As a test, which I did off camera, I get 345 RPM at 24 volts. So actually lower speed than they spec. Right, so going to Amazon, you can see lots of motors look very similar, but as I've shown you, even though motors look similar, they're not the same speed. So this one, for example, scroll down, it says L faster, which if you look on AliExpress, they're all over a place. We've got 200 watts and 1600 RPM. Voltage is a bit vague. Is it 12, or is it 24 volts? Is it 36? And what's that rotation at which voltage? If you go onto AliExpress, some motors will just say they are 24 volts and so many kilometers an hour, so you can roughly work out the speed. This one here again says L faster. If I scroll down, it says, yep, 900 RPM, so difference, yeah, in speed. Whether they are that speed or not, it's hard to tell without buying and testing them. All of this testing is going somewhere, and this is basically the summary of all the censored hub motors I've been testing, as well as a few others, so you people can see the general speeds. So walking speed is about 3 to 4 miles per hour, and I've put all these motors on an old R2 spreadsheet. You've got wheel diameter at the top in inches and millimeters, and the RPM down the side. So Q85 201 RPM motors with a tyre are about 2.7 miles per hour, so about the same as the Senna NPC drives. Next are the Q85 328 RPM, about 4.3 miles per hour. I find these a little bit too fast. It's faster than walking speed, so you do have to sort of do a brisk walk to keep up. Then move on to the 5-inch UU motors, about sort of 5 miles per hour, and then next the hoverboard motor, so about 6.8 miles per hour, so you can see them getting gradually faster. Then we go quite a way down, so for the 4-inch UU motor, got about 7.8 miles per hour, which is, I'd say, pretty fast, so it's double walking speed. Then you've got, if we go full speed on the ones from Amazon, I've said about 890 RPM, which is 10.6 miles per hour. We know from the testing we get 17 kilometers an hour, so ties in 10.6 miles per hour. But these are the sort of maximum speeds. As we've seen, we can change the ERPM to throttle the max speed in these VESC software.